Welcome to Module 1 of Multi-Agent Architect, the foundation. Everything else in the course flows from this premise. Single-session Claude has a ceiling, and that ceiling is real, structural, and predictable. You can't prompt your way around it. You can't think faster to escape it. The fix is to change the shape of the work, not work harder inside the same shape. Module 1 is the diagnosis. We take a hard look at why single-session Claude caps out, context bloat, role confusion, sequential bottleneck. We name the 3 structural reasons subagents win: specialization, parallelism, context isolation. We give you a 5-question framework that decides whether to delegate any specific task. And we apply that framework to your real workflow to surface 5+ delegation candidates you can actually build. By the end of this hour, you'll have the mental model. You'll see your own work differently, places where you've been compensating for the ceiling without realizing it become visible. You'll have a list of candidates ranked by ROI. And you'll walk into Module 2 ready to build the first one. This is the foundation everything else rests on. Let's start. Quick check on whether you're in the right room. Card 1. You use Claude Code daily. Sessions running every week. Terminal open right now. You've put in real reps and you've earned opinions about how the tool behaves at scale. Card 2. You feel the ceiling. Long refactors drift partway through. Reviews turn into rewrites. You know the session quality degrades over time, even if you can't yet articulate why. The instinct is correct. Card 3. You haven't built a subagent yet. You've heard about them. Maybe seen one. Read the docs. But you've never authored your own from scratch and put it into production. If those 3 describe you, you're in the right room. Module 1 is the diagnosis, naming what you already feel, and modules 2 through 7 are the cure. By the end of this course, subagents won't be a concept you've read about. They'll be infrastructure you've built and shipped. 3 deliverables from Module 1. Diagnose the ceiling. By the end of this hour, you can articulate the 3 structural limits of single-session Claude: context window economics, role confusion, sequential bottleneck. The articulation matters because once you can name a problem precisely, you can recognize it in real time and fix it. Recognize the wins. You'll know when specialization, parallelism, or context isolation is the dominant reason a subagent earns its place. The recognition is what stops you from over-engineering with multi-agent systems where single session would do, or under-engineering where multi-agent would actually pay back. Audit your workflows. Score your existing recurring tasks against a 5-question framework. Surface 5+ candidates that genuinely benefit from subagents. The audit is the assignment artifact and the input to Module 2. 5 real candidates from your real work. Ranked. Justified. With dispatch triggers identified. The list is what you walk away with, not theory, but a concrete plan for what to build next. Roadmap for the next hour. For parts. Part 1. Ceiling. The 3 structural limits that cap single-session Claude productivity. We name them. We explain why they're structural. We look at a real before and after example. Part 2. Wins. The 3 structural reasons subagents outperform: specialization, parallelism, context isolation. We also cover the cost dimension, when subagents add overhead instead of removing it, and how to recognize that case. Part 3. Framework. 5 questions that decide whether to delegate any specific task. We work through each question and then run the framework on. Part 1. The single session ceiling. 3 structural limits. 3 structural limits. Preview, then deep dive on each. Limit 1. Context bloat. Every token in your conversation is paid for, and every token competes for the model's attention. As the conversation grows, both cost and quality degrade. Long sessions drift in subtle ways. Early decisions get buried under noise. The agent forgets what was decided. Reasoning becomes less coherent over time. Limit 2. Role confusion. One agent juggling planner plus coder plus reviewer makes worse decisions than three specialists, each with deep domain knowledge. The reviewer's instinct gets dulled by the coder's instinct that just ran. Specialization is a real lever, and single session can't access it. Limit 3. Sequential bottleneck. One session can only work on one thing at a time, even when subtasks are genuinely independent. Three reviewers checking the same diff for security, performance, and tests would naturally run in parallel, but in a single session, you wait for each one in turn. Time burns for no reason. 3 limits. All real. All structural. None of them is a model failure or a prompting failure. The next 3 slides go deep on each, what the limit looks like in practice, and why working harder inside the same shape can't escape it. Limit 1. Context window economics. The principle in 2 parts. Every token is paid for. As the conversation grows, your token bill grows linearly. Long sessions cost more, straightforwardly more in dollars. That's the obvious cost. The non-obvious cost is the second half. Every token also competes for attention. The model's context window has a finite capacity for what it can hold and reason over. Each token added pushes earlier tokens further from the model's working focus. By turn 50, the early context that was important is buried under hundreds of intermediate exchanges. The consequence. Limit 2. Role confusion. The shape that the system prompt forces. Picture a system prompt that says, "You are a senior engineer who plans, codes, reviews, and tests." That sentence sounds fine. It's how you describe a senior engineer in a job listing. But the model interpreting that prompt has to compress all 4 roles into one identity. The identity is necessarily the average of the 4. Deep specialization in any one is impossible. 3 specialists, each with 800 words of focused system prompt, outperform one generalist 8 times out of 10 on any given task. The reviewer specialist has 800 words on what good code review looks like, security patterns, performance heuristics, test coverage criteria. The coder specialist has 800 words on idiomatic patterns. The planner specialist has 800 words on decomposition and trade-offs. The generalist would need 2,400 words to match, and the prompt window doesn't have that much room when you also need to fit the user's actual task. The reviewer instinct is dulled by the coder instinct that just used the same context. The agent that just wrote the code is now reviewing the code. It has biases, it wrote it after all. A separate reviewer specialist comes in fresh. The fresh eyes effect is real and structural. Specialization is the dominant lever for quality. In agents the same way it's the dominant lever in humans. Single session can't access it. Limit 3. Sequential bottleneck. The shape that makes time burn unnecessarily. Look at the diagram. Single session on the left, task A, then task B, then task C, then task D in a chain. Total time, 4 times the longest task. Parallel dispatch on the right, same 4 tasks, running simultaneously. Total time, equal to the slowest single task. The math always favors parallel when the work permits. Same tokens, both versions consume the same amount of model compute. Different time, parallel cuts wall clock by roughly 4 times when you have 4 independent subtasks. The cost in tokens is identical. The time saved is pure value. The constraint is the work has to permit. Subtasks need to have no shared mutable state and no order dependency. If task B needs task A's output, you can't run them in parallel. If they're truly independent, same input through different lenses, different sources for the same query, variance of an output, parallel wins. A single Claude session is structurally serial. It can only do one thing at a time, even when the work is naturally parallel. The bottleneck is the shape, not the model. Multi-agent breaks the shape. A single session can't. The compounding error problem. 5 symptoms that add up to broken sessions. Drift. The agent loses sight of original instructions over many turns. The conversation pulls toward whatever was discussed most recently, The early constraints fade. Lost context. Early decisions buried under noise. The agent claims it doesn't remember what was decided about a structural choice an hour ago, and structurally, it doesn't, because that decision is far from its working focus now. Hallucinated state. The agent claims something is true that was actually decided otherwise. Not deliberately, the model is confabulating from a degraded view of the conversation history. Compounding errors. Each bad turn becomes input to the next bad turn. A small drift on turn 10 becomes a slightly larger drift on turn 12, which becomes a noticeable problem on turn 15. By turn 50, the cumulative drift is dramatic. By turn 50, you're not arguing with the agent that started the session. The working memory has degraded enough that the agent's responses are coming from a meaningfully different context than the one you originally established. Compounding is silent. A real example. Same refactor task. 2 shapes. Single session, 90 minutes. 20 minutes exploring the codebase to understand what's there. 20 minutes writing the refactor plan based on the exploration. 30 minutes applying the changes, but partway through, drift sets in, and the changes start contradicting earlier ones. 20 minutes at the end fixing the bugs the drift introduced. Multi-agent, 25 minutes. 5-minute Explorer agent reads the codebase in its own session and returns a structured summary. 5-minute Planner agent takes the summary and writes a clean spec. 10-minute Builder agent applies the spec to the actual code. 5-minute Reviewer agent verifies and approves. Total, 25 minutes, end to end. Same model, same task. The shape changes the outcome dramatically. The single session burns time on drift recovery. The multi-agent system never accumulates the drift in the first place because each agent has a clean, focused context. The numbers aren't cherry-picked. They're representative of what teams report when they switch from single session to multi-agent on workflows that have the right shape. A 4-time speed-up with higher quality is normal. The win comes from removing the structural overhead, not from working harder. The ceiling visualized. After 30 minutes of conversation, every additional turn produces roughly 70% the value of the previous one. The slope is real. The ceiling is real. You felt this without naming it. The first hour with Claude is electric, clean context, focused exchanges, fast iteration. The second hour is solid but a step down. The third hour, you notice you're explaining things you already explained. The fourth hour, you're managing the agent more than collaborating with it. By the end of the day, the same tool that felt like magic in the morning feels like work. The fix is structural, not a better prompt. You can't prompt your way around context bloat. The bloat is happening at the model layer below your prompts. You can't roleplay your way around role confusion. The role compression is happening before any roleplay instruction can take effect. You can't think faster to escape the sequential bottleneck. The wall clock is what it is. The fix is to change the shape, break the work into specialized agents, dispatch them in parallel where possible, and offload heavy reading to context sinks. That's multi-agent. That's why the rest of this course exists. The ceiling is structural. The fix is structural. Multi-agent is the fix. Part 2. Why subagents win. 3 structural reasons that mirror the 3 structural ceilings. 3 reasons subagents win. Each maps directly to one of Part 1's structural limits. Reason 1. Specialization. A focused system prompt outperforms a kitchen sink one. This fixes role confusion. Instead of one agent doing planner plus coder plus reviewer, you have 3 specialists each with deep domain knowledge. Reason 2. Parallelism. Independent subtasks run concurrently, not serially. This fixes the sequential bottleneck. 3 reviewers fan out and complete in the time of the slowest one, instead of in the sum of all 3. Reason 3. Context isolation. Heavy reading is offloaded to subagents that absorb the noise. The main agent's context stays clean. This fixes context bloat. The noise never reaches the parent in the first place. Each reason is the structural counterpart to a structural limit. The fixes are structural in the same way the limits are. You can't fix context bloat with better prompting. You fix it by isolating context. You can't fix role confusion with longer prompts. You fix it with specialization. You can't fix the sequential bottleneck with faster thinking. You fix it with parallelism. The next 3 slides go deep on each reason, what it looks like in practice, when it matters most, and how to recognize when it's the dominant reason for delegation. Reason 1. Specialization. The lever that drives most multi-agent wins. Each specialist gets 800 words of deep domain knowledge. The security specialist has 800 words on common vulnerability patterns, OWASP categories, threat models. The performance specialist has 800 words on profiling, hot paths, common bottlenecks. Each specialist's prompt is dense and focused. The generalist would need to carry all of it, 800 words for security, 800 for performance, 800 for tests, 800 for style. That's 3,200 words just for the role descriptions, before any task content. The prompt window doesn't have that much room. So the generalist gets a compressed, diluted version of each domain, and the dilution shows up in the output. Smaller, denser system prompts mean sharper reasoning per task. The model has more attention to spend on the actual work because less of its context is consumed by role juggling. Quality goes up while cost stays the same. Pure win when the work has clear subdomains. Specialization is the dominant reason for over 70% of multi-agent wins. If a single agent's prompt would need to span 3 different domains to do the job well, you want 3 agents. The split itself is the value. When you see a task that requires expertise in multiple domains simultaneously, that's the specialization signal. Break it into specialists. Reason 2. Parallelism. The cleanest delegation case when it applies. Independent subtasks have no shared mutable state. Each task can run without waiting for any other task. The classic example is multi-perspective review. 3 reviewers fanning out on the same code, each looking at it through a different lens. Security reviewer doesn't need the performance reviewer's output. Performance reviewer doesn't need the test reviewer's output. They're parallel because they're independent. Walk clock time becomes the slowest task, not the sum of all tasks. If each reviewer takes 30 seconds, 3 in parallel finish in 30-something seconds. 3 sequentially would take 90. The wall clock savings are real and immediate. Token cost is identical to sequential. Both versions burn the same compute. The parallel version just orchestrates it concurrently. So the trade-off is same cost, less time, which is pure value with no downside when the work is genuinely parallel. The constraint matters. The work has to permit parallelism. Subtasks must have no shared mutable state. No agent can be writing to a file the other agents are reading. Subtasks must have no order dependency. Task B can't need Task A's output. If those constraints aren't met, parallelism is the wrong lever. Sequential pipeline is the right one. Parallelism turns minutes into seconds when the work permits. The work has to permit, but when it does, the win is among the cleanest you'll get from multi-agent. Reason 3. Context isolation. The discipline that makes long sessions viable. Heavy reading burns parent context. Reading a 5,000-line log consumes 50,000 tokens of context window. Reading an unfamiliar codebase to find a single bug consumes hundreds of thousands of tokens of cumulative file reads. If the main agent does this reading, its context bloats and its reasoning quality drops, the limit 1 ceiling kicking in. Subagents read in their own sessions and return tight summaries. The subagent absorbs the reading work. The main agent gets a 280-character finding plus an evidence list, file path, line number. The cost dimension. Subagents unlock tiered model selection. The number on screen is approximately 50. That's the cost spread between Haiku and Opus per token. Haiku is roughly 50 times cheaper to run than Opus on a per token basis. The spread is significant, and it compounds across the many calls a multi-agent system makes. Subagents let you tier model choice per task. A narrow extraction task, pull the security issues out of this code review, runs fine on Haiku at 50 times lower cost. The orchestrator that decides routing and integrates results runs on Opus, where you need the full capability. The middle workhorse tier. Anti-pattern. Delegating just because you can. Subagents add overhead. The orchestration tax is real. Every dispatch costs tokens for the prompt to the subagent plus tokens for the return. Wall clock includes dispatch overhead, not just subagent runtime. Handoffs introduce contract risks, schema mismatches, lost data, ambiguous returns. If a single agent could do the task cleanly in 10 turns, single session wins. The threshold matters. Subagents earn their keep when one of the 3 structural reasons applies: specialization, parallelism, or context isolation. Without one of those reasons, you're paying over 5 signals to keep it single session. The mirror of the delegation framework. When to skip multi-agent. 1. The task fits in a 5-turn happy path on the first try. Quick lint fixes, simple refactors, single file edits. These don't need orchestration. The dispatch overhead exceeds the value. 2. All the context the subagent would need is already in the parent. If the parent has read the file and is holding the diff, dispatching a subagent to look at the same diff just adds round trips. Context isolation only helps when the subagent has reading work the parent doesn't have to do. 3. The return data would be 90% of what the subagent saw. No compression value. If the subagent's job is to summarize a file and the summary is essentially the file restated, you've gained nothing. You've just paid for an extra round trip. 4. Sequential dependencies. Every step needs the previous step's output. If task A's output feeds task B's input, which feeds task C's input, that's a pipeline, not a parallel dispatch. Pipelines work in single session too. The multi-agent value comes mostly from parallelism. 5. You're prototyping. Orchestration overhead exceeds the work itself. When you're exploring or iterating quickly, single session keeps the loop tight. Part 3. The Delegation Framework. 5 questions, 1 decision. The framework. 5 questions. Run any task through them. Question 1. Is this task self-contained with clear inputs and outputs? Question 2. Will the result fit a short summary? Or do I need the full reasoning trace? Question 3. Could this run in parallel with other work? Question 4. Is the context cost of doing it inline higher than the dispatch overhead? Question 5. Is this a repeat task worth turning into reusable infrastructure? 3 or more, yes, delegate. 2 or fewer, single session is fine. The framework is binary on purpose. It stops the endless should I, shouldn't I loop and forces a decision. The decision might be wrong sometimes. That's fine. You correct on the next pass. The point is to have a tool that produces a decision in under a minute. The next 5 slides take each question one by one. We talk about what the question is really asking, how to answer it cleanly, and what the answer tells you about whether to delegate. Then we run the framework on 3 real tasks to show it producing decisions in real time. Question 1. Self-contained with clear inputs and outputs. Inputs are nameable. You can describe what goes in as a file path, a query string, a structured object, something specific. If the input is, use your judgment based on the conversation so far, that's not a clean input. The task is too coupled to its surrounding context to delegate cleanly. Outputs are nameable. You can describe what comes out, a verdict, a list of issues, a parsed JSON object. If the output is an opinion that depends on what you find, that's not a clean output. No constant back and forth needed mid-task. The subagent should be able to run from input to output. Question 2. Summary or full reasoning trace. If a 280-character summary captures the value, subagent wins on context isolation. The parent gets the answer without the noise. The subagent absorbs the source material. The parent makes decisions on the compressed signal. If you need the full reasoning to make the next decision, single session wins because dispatch loses information. Some tasks have value in the journey, not just the destination. When you're debugging a tricky bug and need to see every hypothesis the agent considered, the trace is the value. Compressing it to a verdict throws away the part that mattered. Find the bug needs the trace. You need to follow the reasoning to learn what the agent learned, so you can verify, extend, or pivot. Stay in line. Is there a bug? Wants the verdict. You just need the answer to act on. Delegate. The phrasing of the question often reveals which mode the work is in. Most evaluation tasks compress to summaries, code review, security audit, performance check. Most exploration tasks don't compress. Debugging, researching unfamiliar systems, understanding complex flows. When in doubt, ask, would a one-paragraph summary suffice? If yes, delegate. If no, stay in line. Compression decides. If it compresses, sub-agent. If it doesn't, single session. Question 3. Could this run in parallel with other work? 3 signals that say yes. Same input through different lenses. Same code reviewed for security, performance, and test coverage simultaneously. The work is naturally parallel because each lens is independent. Different sources for the same query. Research a topic by querying Arxiv, internal docs, and the web simultaneously. Each source returns its findings independently. The parent integrates after. Variants of an output. 3 different add copy options, 3 different naming candidates, 3 different design directions. Generate them in parallel and let the human or a synthesizer pick. The constraint is straightforward. Subtasks must have no shared mutable state, no 2 agents writing to the same file, no 2 agents needing to coordinate mid-flight. Subtasks must have no order dependency. Task B can't need Task A's output. If those conditions hold, parallel wins. Parallelable tasks are the cleanest delegation case the framework finds. The math always favors them. Same tokens, less time, no quality loss. When question 3 returns yes, the task is a strong delegation candidate even before you check the other questions. Parallel turns minutes into seconds when the work permits. Watch for this signal. It's the most powerful one in the framework. Question 4. Context cost versus dispatch overhead. The arithmetic that decides whether the subagent earns its keep on big tasks. Reading a 5,000-line log inline burns roughly 50,000 tokens of parent context. That's a significant chunk of the parent's working memory consumed by source material. Dispatching a subagent to read that same log costs roughly 500 tokens for the dispatch prompt plus 280 for the structured return. Total dispatch overhead, under 1,000 tokens. Net savings, roughly 49,000 tokens of parent context preserved for actual reasoning. The math isn't close. When the artifact is... Question 5. Repeat task worth turning into reusable infrastructure? Tasks you do 3 or more times per week deserve a subagent. The build cost, couple hours to author the agent file, test it, install it, pays back fast when the task recurs. The first invocation is slower than ad hoc. The 10th is much faster. By the 20th, the subagent is paying for itself many times over. Tasks done once a quarter rarely earn the build cost. Even if the task is delegation-shaped on the other 4 questions, if it only happens 4 times a year, the build cost may exceed the cumulative savings. Stay ad hoc. Subagents. The framework on 3 real tasks. Watch it produce decisions. Task 1. Code review on a diff. Question 1. Self-contained? Yes, the diff is a clear input. 2. Summary? Yes. Verdict plus issues fits a summary. 3. Parallel? Yes. Multi-perspective review is the canonical parallel pattern. 4. Context cost? Yes. Big diffs burn parent context. 5. Repeatable? Yes, code review happens daily. 5. Yes. Verdict. Delegate. Task 2. Quick lint fix. 1. Self-contained? Yes, the file is the input. 2. Summary? Doesn't really matter for a one-line fix. 3. Parallel? No, it's a single change. 4. Context cost? No, the file is small. 5. Repeatable? No, each lint fix is unique. 1. Yes, for no's or n/a's. Verdict, stay in line. The dispatch overhead exceeds the work. Task 3. Research current API documentation. 1. Self-contained? Yes, the API name is the input. 2. Summary? Yes, key facts compressed nicely. 3. Parallel? Not really, you're hitting one source. 4. Context cost? Yes, docs are large. 5. Repeatable? Yes, API research recurs. 4. Yes. Verdict, delegate. 3. Yes or more means delegate. 2 or fewer means stay in line. The framework produces decisions in under a minute and stops the endless deliberation loop. Part 4. Audit your workflow. Apply the framework to your real work and rank the candidates by ROI. Step 1 of the audit. Inventory. List every recurring Claude Code task in your work. Open your last 30 days of Claude Code sessions. Most editors and terminals keep the history. Pull it up. Skim through what you actually use Claude for. Note every recurring task. Code review. Refactor planning. Debug investigations. API research. Documentation lookups. Test writing. Whatever shows up. The criterion is recurrence. Anything you've done more than once. Don't filter yet. The temptation is to immediately decide, oh, that's not a subagent candidate. Resist. The filtering happens later with a framework. Right now, capture everything. Aim for 15 to 20 raw items in the inventory. If you have fewer, you're filtering already. Loosen up. If you have more, you're probably double counting. Consolidate. The 15 to 20 range is the sweet spot for a useful audit. The inventory is the input to the framework. Without a real, complete inventory, the framework has nothing to operate on. The inventory is messy on purpose. Many of these items won't end up as subagents. The framework's job is to clean up the mess. The inventory's job is to surface everything that could possibly be a candidate. Step 2. Score each task on 3 axes. Frequency. How often do you do this task? Daily, weekly, monthly, or quarterly? Score 0 to 3. Daily gets a 3, weekly a 2, monthly a 1, quarterly a 0. Higher frequency means more value from automation. Current pain. How bad is the experience in line? Slow, error-prone, drift-prone, frustrating? Score 0 to 3. High pain gets a 3, neutral gets a 1, pleasant gets a 0. Higher pain means more value from getting it out of single session. Delegation fit. How many of the framework's 5 questions get a yes? Score 0 to 3. 3 or more yes gets a 3, 2 yes gets a 2, 1 yes gets a 1, 0 yes gets a 0. Higher delegation fit means the task is structurally suited for subagents. Each axis scored 0 to 3. Total score 0 to 9. The total is your candidate's overall fit, how recurring, how painful inline, and how delegation shaped. The highest totals are your top subagent candidates. Items scoring 8 or 9 deserve serious build effort. 6 or 7 is borderline. Build only if you have time. 5 or below. Skip for now. Step 3. Apply the framework to the top 10. Take the top 10 by total score from your inventory. Cap at 10. Even with a great inventory, you can't build 20 subagents at once, and the framework should filter further anyway. Run each through the 5-question framework. Q1 self-contained, Q2 summary or trace, Q3 parallel, Q4 context cost, Q5 repeatable. Mark each yes or no. Filter to the candidates with 3 or more yes. These are delegation-worthy in framework terms. The 2 or fewer yes candidates stay in line for now. They may earn a subagent later as the framework's signals shift, but for the assignment, focus on the survivors. Expect 5 to 7 candidates to survive. The audit is calibrated to produce a manageable list. If your survivor list is 12, your framework scoring was too lenient, regrade. If it's 2, you were too strict, regrade. The 5 to 7 range is what produces actionable work. The framework is the gate. Most candidates won't pass, that's correct. The gate exists to keep you from building 12 subagents that don't compound. 5 well-chosen subagents that match your real workflow will do more for your productivity than 12 mediocre ones that don't quite fit. Step 4. Rank by ROI. Impact equals frequency times pain divided by alternative cost. A task you do daily that's painful inline where the alternative, single session, is actively losing time, scores high impact. A task you do weekly that's mildly painful where single session works fine, scores low impact. Build effort. Step 5. Identify dispatch triggers. How does each agent actually get invoked when the time comes? Keyword trigger. The user types phrasings like review my code or check my function, and the orchestrator routes to the reviewer agent. Keywords are the most common trigger and the easiest to implement. List the phrasings in the agent's description. File pattern trigger. A pull request touches files matching a pattern like star.ts, and a TypeScript specialist agent activates. File patterns are useful when the trigger is structural rather than verbal. Explicit invocation. A /command, /review, /audit. The user types it, the agent fires. /commands give clarity at the cost of memorization. Users have to know the command exists. Hook trigger. Pre-tool use hook fires the agent automatically before a specific tool runs. Hook triggers are powerful for guardrails. They ensure the agent runs every time, regardless of whether the user remembered. Each candidate needs at least one trigger, ideally 2 for robustness. A keyword plus a /command means users can either type naturally or type explicitly. Both paths work. Without a trigger, the agent never runs. Without 2 triggers, it runs unreliably. Identify both before declaring the candidate done. What the audit table looks like. For columns, candidate, the name of the task that survived the framework, code review, doc research, dependency check, 1 row per candidate, rationale, a brief justification for why this candidate earned a subagent, pull from your scoring, self-contained, verdict fits summary, big context, clear contract, repeated, parallelable. 3 or 4 words. It's a justification, not an essay. Expected gain. Time savings per week if you build the agent. 60 minutes per week. 45 minutes per week. 30 minutes per week. Be specific. The number forces the value question. If your estimate is save some time, the candidate isn't ready. Trigger. The dispatch mechanism. /review. Keyword docs. Pre-tool use hook. Specific and unambiguous. You should be able to test the trigger after you build the agent. For columns, 1 row per candidate, 5 rows total. That's the assignment artifact. The table is what you submit. The discipline of formatting it forces clarity on every dimension that matters. A real example audit. 5 candidates from 1 real workflow. Code review on PR diffs. 5 framework yes. 1 hour per week saved. Trigger, /review. Stack trace tria. For yes. Needs the trace partly. 30 minutes per week. Trigger, keyword error. Doc lookups for new APIs. 5 yes. Clear contract. 45 minutes per week. Trigger, keyword docs. Ref factor planning. For yes. High context cost makes it a strong candidate even though parallelism doesn't apply. 1.5 hours per week. Trigger, /plan. Dependency vulnerability check. 5 yes. Parallelable across many packages. 20 minutes per week. Trigger, Pre-tool use, hook on, package, install. Total expected gain, more than 4 hours per week reclaimed. Across a year, that's roughly 200 hours, 5 working weeks of time recovered just from these 5 candidates. The audit is how you find that time. Without the audit, the gains are vague intuition that something might help. With it, they're a specific list, each candidate named, each savings quantified, each trigger identified. The list becomes a plan. The plan becomes Module 2's first build. Quick recap. 5 capabilities by the end of the hour. You can diagnose the single session ceiling, 3 structural limits, named precisely. You can articulate why subagents win, 3 structural reasons that map to those limits. You can apply the 5-question framework to any task and produce a delegate or not decision in under a minute. You can audit your own workflow against the framework. You can rank delegation candidates by ROI. The Module 1 assignment. Audit your workflow. 5 subagent candidates. 3 deliverables. 5 workflows where the framework returns 3 or more yes. Rationale, expected weekly gain, and trigger documented per row. The 5-row table submitted as the artifact. The audit is the input to Module 2. Module 2 takes your top candidate and walks you through building the actual subagent, front matter, description, tools, system prompt. Without the audit, Module 2 has nothing to build against. With it, you walk into Module 2 with a specific candidate and clear specifications. 3 concrete actions on 3 time horizons. Today. Inventory your last 30 days of Claude sessions. List every recurring task. Don't filter. Aim for 15 to 20 raw items. 30 minutes, set a timer. The inventory is the rough draft your framework will polish. This week, score the inventory on 3 axes: frequency, current pain, delegation fit. Run the framework on the top 10. Filter to the survivors. Rank by ROI. The output is a ranked list of 5 to 7 candidates with framework yes and ROI estimates. This month, submit the 5-row audit table. Up next, Module 2. Anatomy of a production subagent. Where Module 1 taught you when to delegate, Module 2 teaches you how to author the actual subagent file. 4 topics. Front matter contract. Name, description, model, tools, the 4 required fields and what each one buys you. The field that decides whether your agent loads at all. Descriptions that trigger. The single most important field in the file. We dedicate a full lesson to it because in practice it dominates every other failure mode. Capability plus when to use plus when not to use, with embedded examples that anchor the router. Tool selection. Principle of least. Module 1 in the course arc. The foundation everything else rests on. Module 1, mental model. You're here. Module 2, anatomy. Module 3, primitives. Module 4, patterns. Module 5, system design. Module 6, packaging. Module 7, capstone. The arc compounds. Module 1's audit is Module 2's input. Module 2's agent is Module 3's substrate for composing primitives. Module 3's mini-system is Module 4's substrate for picking patterns. Module 4